Hello, Chem students. Today we are discussing the differences between accurate and precise. Accuracy is the degree of conformity with a standard or how close a number is to its accepted value. Standards are also known as true, accepted, or theoretical values. Precision is how close measurements are to each other. So if you have three measurements and they are all close to one another, then that data is considered precise, much like the arrows here. Let's do some examples. We need to determine if the data points here are accurate and/or precise. Remember, accurate is how close the data is to the accepted value. On a bullseye, our goal or accepted value would be the center of the bullseye. Is the average of these data points close to the center? No, they are not, so they would not be considered accurate. Precision is how close your data points are to each other. Are these data points close to each other? Yes, so they would be considered precise. Next example. Would the average of these data points be close to the standard or center? Yes, they are. So they would be considered accurate. Are the data points close to each other? Now, precise would be no more than one marking away from each other. Each of these rings is a marking. So if the distance between each of the points is more than the distance between a ring, then they would not be close or not precise. Next example. Are the average of these markings close to the standard? Yes, they are, so the data is considered accurate. Are the data points close to each other, or are they within the distance of one marking? Yes, they are, so the data is also considered precise. In our last example, is the average of the data points close to the standard or center of the bullseye? No, it is not, so it would not be considered accurate. Are the data points close to one another or within the distance of one marking? No, they are not, so they would not be considered precise. Now let's do some examples with actual lab data. 4 lab groups performed the same experiment 3 times to determine the melting point of naphthalene. The accepted melting point is 79 degrees Celsius. Is the average of the data close to the accepted value? The average is 79, so yes, the average is close to the accepted value, so the data is accurate. Now let's determine if the data is precise. Are the data points close to each other? Remember, they must be within one marking of each other to be precise. We take the second to last number as the marking. In this data, the second to last marking is the ones place, so each piece of data would need to be within 1 degree of each other to be precise. The easiest way to determine this would be to take the highest number and subtract the lowest number. If the difference is greater than 1, it is not precise. This data has a difference of 5.1, so the data is not precise. Group 2's data. Is it accurate, or is the average close to the accepted value of 79 degrees Celsius? The average is 76.2, which is 2.8 degrees off, which is more than our 1 degree, so it is not accurate. Is it precise though? Well, the difference between the highest data point and the lowest data point is 0.2 degrees, which is less than 1 degree. So the data points are close to each other, so they are precise. Is Group 3's data accurate? Remember, accurate is the average close to the accepted value. Here we are taking our 1 degree, plus or minus 1 degree. The trials are neither close to each other nor close to the accepted value of 79, so they are not accurate and they are not precise. Let's look at Groups 4 data. Is it accurate? Is it close to the accepted value? And are they precise? Are they close to each other? All trials are close to each other and close to the accepted value of 79 degrees, so they are both accurate and precise. Qualitative measurements are non-numerical and descriptive data or approximate values if it is a numerical piece of data. An example would be approximately 20 milliliters of water. Quantitative measurements are numerical information and precise values. An example would be precisely 20.5 milliliters of water. Let's talk about glassware that we use in the lab and determine by its descriptions if it is a qualitative piece of equipment or a quantitative piece of equipment. Remember, approximate indicates qualitative and precise indicates quantitative. Beakers hold approximate volumes, which means it's qualitative. Burettes are used to precisely deliver, so it's quantitative. Erlenmeyer flask used to contain approximate volumes, so it's qualitative. Graduated cylinders are used to measure and deliver precise volumes, so it is quantitative. Pipettes used to precisely deliver, so it's quantitative. Test tube holds liquids. If the labware is only used to hold and not to measure, then it is qualitative. Volumetric flask precisely contains specific volumes, so it would be a quantitative piece of equipment. Thanks for watching.